hydrogen mobility. Apart from that, we are also creating a 200 kilowatt green hydrogen based microgrid at Ladakh, one of our very difficult sites, which we have taken up as a challenge. We are going to go now aggressively into green ammonia and other chemical products at our hydrogen hub, Podimatka. I'll be sharing with you some of the details of this project as we move forward. We are also trying to work on the fuel cells for our hydrogen locomotive at Sipat. So this would help in basically these pilot projects would help in clearing the air as to the efficacy of hydrogen into these sectors. And locomotive, one of the main motive force of the huge coal that is being brought not only in NTPC but in other power utilities also. So if this is proved to be successful and also as we well forward commercially viable, this would go a long way in this. Just in brief, the strategy of NTPC, we want to reach the leadership position in green hydrogen technologies. Our idea is to set up a 5 gigawatt RERTC, that is around the clock power for fueling our this green chemicals. We are in the process of installation of 4 gigawatt of electrolyzer capacities. And by the year 2032, our plan is to be able to produce 2 MMTP of green chemicals. This was what I just discussed, the green blending with natural gas. This, as I just told, this has been giving power to almost 200 households. Since December 2023, we are having an 8% volume blending report, and this we have submitted to PNJRB. Once this is approved, then we'll be going in for 15% blending. And the effect of this would be out of 30 MMSCMD of CGD that is currently there, 2% blending would result in a saving of around 0.12 million tons of CO2 per annum. On the mobility sector, sir, 2 projects that I just said. One is the green hydrogen mobility project at Leh, and the other one at Greater Noida. We are setting up a 1.70 megawatt solar plant to produce hydrogen there at Leh. This is, I'm happy to inform that we almost reached the final commissioning stage, and we would be producing there with the help of this 80 kg per day. And finally, for the final result, Ashok Leland will be our partner who will be supplying the hydrogen bus. So we will be having almost 5 number of buses, and this would on a daily basis be able to cover 200 kilometer range per bus, that means 1,000 kilometer per day. That's enough to prove. And once this is proved, the healthiness of this in the Leh domain, then this will be, I would say, a great development. Likewise, that is basically intracity. At sub-zero temperatures and high altitude, we are looking for an abatement of around 280 tons per annum of CO2 with this project. Coming down now, we are setting up similar project at Greater Noida, but on a larger scale, almost 3 times the scale of the one that we have planning to set up at Leh. This would be an intercity long haul, and basically the Delhi climate. And this would be huge saving of around 850 tons per annum of CO2 abatement. This would also run around, one bus would be able to run around 600 kilometer range. So this would be a great testament as to see whether intrastate or distance mobility can be a real thing as far as hydrogen is concerned. This is again a 200 kilowatt green hydrogen microgrid at Chusul, Ladakh, which we are contemplating, and this would produce around 200 kg hydrogen at 250 bar, which would be given to a hydrogen compressor unit to fuel cell. This is a unique project that we are taking about for at very high altitude and at very difficult, I would say, conditions. And hopefully we will be completing this one also soon. This is our flagship project, sir, which I wanted to tell the audience. This we are going to set up at Pudimatka, Visakhapatnam, Andhra Pradesh. This would be a hydrogen hub with plug and play facilities, which we plan to develop, not only for us, but for other developers also to come in and pitch in there on that. That will be a 1,200 acre at an investment of around 1,006 crores land size. It is near to the road network, and seaport is very near to it. It has all the essentialities that are required and that you must have heard in the previous sessions also, which are required for a great hydrogen hub. So the water source is also over there. The power supply would be from our plant of NTPC Simantri, which is nearby. And initially, so this Andhra Pradesh government would be our preferred partner in this, and they have given us the clearance for moving ahead on this. We are also looking for some additional land to set up our desalination plant and other things, which is of around. This would come around, the timelines for this would be around 2032. This would be, we have already started the feasibility works and have started to put our investment there. So in a nutshell, sir, this is the broad framework on which we work. The hydrogen policy, hub policy alignment with the National Green Hydrogen Mission. Then we have the demand potential domestic and export market for green chemicals, which we have studied. There will be an investment to the tune of almost $22 billion, 185,000 crores. The infrastructure would require a transmission corridor of a 7 gigawatt GIS 50 and desalination plant would be there. Desalination and setting up of other admin building, ATP chemical storage, etc. This project, as you can see, is more than the pilot. It's going to be the first big hydrogen hub, let's say, that we are going to develop, and it's going to be a great step towards the hydrogen capacity that we plan for that. This is another project very dear to us. This is the hydrogen locomotive that we are trying to do. This will be powered by a fuel cell of 600 kilowatt, hydrogen on board 100 kg at 350 bar, battery on board at 1000 kilowatt, 500 kilowatt hour. We will be having a solar PV plant 3 megawatt and an electrolyzer of the size of 1.6 megawatt. Apart from that, yes, I just forgot to mention in my initial talk that apart from that, we are also doing on the R&D network side a couple of carbon capture technology projects, CO2 methanol, CO2 generation to fourth generation ethanol, 333 TPA plant, which we are setting up at NTPC Lara, the first one at NTPC Vindhyachal, and then we are also planning for a CO2 waste carbonated coarse aggregate. CO2 to green urea, CO2 storage to category 1 coal. So perhaps as I just explained, we are as PSU in all domains of green hydrogen, wherein we want to bring and prove that India will come up as a big player in green hydrogen. Green hydrogen and some of our other hydrogen technology projects that we are taking up, which includes the green hydrogen from seawater. This is another very unique initiative that green hydrogen we are planning to produce from seawater. Waste heat or flue gas would be used to produce hydrogen, created water, hence this may come at a very low cost. Likewise, again, on the conservation front, we are also planning for green hydrogen, STP water, and plasma oxy gasification based green hydrogen. So thank you, ladies and gentlemen. It was a pleasure to address you. This is a brief snapshot. I wanted to present this for the audience on the green hydrogen. So thank you once again.
स्पीड ही नहीं आ रही हमारी नेट पे। ये इनका है ना। अवयव प्रबल
My co-panelists, distinguished participants, welcome to the presentation on 4.3 tons per day green hydrogen pilot plant set up by GAIL in India. So just to set the context, we all know that climate change is now here. Warming over the past 30 years has been much faster than the long-term trend. We also know about the concept of 1.5 degrees C. We are now on course to achieve a level of upwards of 2.6 degrees rather than the goal of 1.5 which was set at the Paris. So basically to curb the effects of global warming and to meet the 1.5 degrees C goal, the world now needs to move to net zero. India has also committed a lot at the COP26. In fact, our Honorable Prime Minister presented to the world 5 elements known as Panchamrit, and these are we will be achieving 500 gigawatts of non-fossil fuel based energy capacity by 2030, 50% of the energy requirements from renewable energy, reduction of 1 billion tons in the total projected carbon emissions, reducing the carbon intensity by less than 45%, and achieving net zero by 2070. As part of this, slightly earlier during August, on the 75th Independence Day, the government had announced National Hydrogen Mission, which includes important milestones like energy independence by 2047, a mission to enable cost reduction of electrolyzer and renewable energy, policy for transmission, connectivity, banking, open access, and storage for green hydrogen, upscaling production and deployment of high-performance electrolyzers, and lastly, to develop a robust domestic electrolyzer manufacturing facility. As part of this, there are various objectives. The first one is to produce at least 5 million tons of green hydrogen. This has been recently upscaled to 7.5 to replace gray hydrogen produced from fossil fuel sources with green hydrogen in petroleum refining and fertilizers, to progressively blend green hydrogen in CGD systems, to shift heavy-duty long-haul mobility to vehicles powered by green hydrogen, and to shift steel production to low-carbon routes using green hydrogen, and lastly, to emerge as a hub for production and export of green hydrogen and green ammonia. We all know about this. There are various classifications of hydrogen, so we'll be talking only about the green hydrogen here. So GAIL's transition towards clean energies. Natural gas, as we know, is the cleanest fossil fuel and has the lowest carbon intensity among the fossil fuels like petrol, diesel, coal, etc. And India has already targeted to boost the natural gas share in the primary energy mix from 6.7% now to about 15% by the year 2030. We are already operating about 16,000 kilometers of natural gas pipelines and working to expand this network much ahead. By switching over to NG as a fuel, GAIL is in fact helping other industries lower their GHG emissions. So the increase in operations of GAIL in fact helps India achieve lower emissions as such. But during the course of our operations, we also consume small bit of natural gas and also emit CO2. So we have to do certain steps to reduce the or to achieve this goal of net zero within GAIL. For this purpose, we already have a renewable energy portfolio of 135 megawatt, and we are planning to increase it manifold to about 1,700 megawatt by 2030. In response to the net zero targets of the government, we have announced a very ambitious net zero target of achieving 100% reduction in scope 1 and scope 2 by 2035 and a 35% reduction in scope 3 by 2040. A three-pronged approach we are following. First is the avoidance scenario. So our management has decided that whatever new projects are implemented from now on, they will be net zero. So the net zero concept will be inbuilt in the IRR calculations, and whatever extra power is required for those projects will be making additional renewable energy for those projects. Second is the mitigation for the existing CO2 emissions, for which various abatement options are there, like electrification of existing energy-based equipment, renewable energy, green hydrogen, CBG, CO2 valorization, and energy efficiency. In this, green hydrogen plays a very important role for us because green hydrogen and CBG, these are the only two substitutes which can replace energy as a fuel. And last is offsetting, afforestation, and if we are not able to achieve some of the targets, we may have to purchase carbon units from the open market. The initiatives which have already been undertaken by GAIL are, we started India's maiden pilot project of blending hydrogen in CGD systems by blending 2% of hydrogen in CGD network of Avantika Gas Limited at Indore, which has now been gradually increased to 5% in the PNG network. GAIL has also set up India's first 10 electrolyzer-based green hydrogen plant at Vijaypur to produce about 4.3 tons per day of green hydrogen. This plant was inaugurated in the month of May by Honorable Secretary to Ministry of Petroleum, Shri Pankaj. So some of the important features of this hydrogen pilot plant are, it is produced through electrolysis, a process which separates water into hydrogen and oxygen using electricity generated from renewable energy. So we are setting up a 10 megawatt renewable energy solar based also, which will supply the power to this unit. And PEM electrolysis is a very simple concept. You put in H2O on one end at the anode, and you get O2 on the same end, and the hydrogen molecule passes through the membrane, and on the other side you have cathode, and it converts again back to hydrogen. And it is safer, and it requires very less time for startup and shutdown. The turn-down ratio is also pretty low at 20%. These are some of the additional features of the PEM electrolyzer set up by GAIL. It is supplied by Cummins, USA. The capacity is 4.3 tons per day. The second feed is DM water, about 45 meters per hour. And we get hydrogen, which is very pure, 99.99%, and with a moisture and oxygen of less than 5 ppm. The power is renewable, 10 megawatt, and the specific energy consumption is working out to be 55 units per kg of hydrogen. Technimont was our EPC contractor, and NEL was the PMC for this project. This is one more schematic of this project. We supply AC voltage at 6.6 kV to the transformer, and it gets reduced to 900 volt AC, which comes to the rectifier, which and the DM water also we supply from our existing boiler in the LPG plant, which has a conductivity of about 1.5 microsiemens per second, and this conductivity has to be reduced further in the DI unit. And this rectifier and DI water, this is the inside the battery limit of the plant, and these two inputs are given to the electrolyzer, and we get oxygen on one side along with some moisture. The moisture is removed and the pure oxygen is released into the atmosphere at present. And regarding hydrogen, we have a water separator and a two-stage dryers. In the first stage dryer, we have an oxidation process, catalytic process, which converts the oxygen, whatever is present in this state, it reacts with the hydrogen and produces water. And this water is removed from the absorber unit, which is the second stage. So we get almost very pure hydrogen and dry hydrogen on the other side. This I've already told. Deoxo stage is the first stage of the dryer, and the second stage is the absorber vessel, which is a two-step process. Hydrogen utilization, presently we feel that this would be used for various sectors like fertilizer, refinery, steel plants, etc. And transportation can be either through a dedicated hydrogen pipeline or blending green hydrogen in our existing energy pipeline. So these are the various options for which hydrogen would be useful. The benefits of hydrogen blending are carbon emission reduction. Hydrogen as such, we know that it is a very clean fuel. So it has a calorific value which is about 2.5 times of natural gas. So if we blend 5% of hydrogen in the gas, about 12% to 15% reduction in CO2 emissions takes place. Besides that, the existing network is capable enough to transport the gas, so we don't need to put up additional infrastructure. And lastly, and most important, it can provide energy security because the fossil fuels are being imported and this can be produced within India. So the way forward is we are operating the plant at present and we plan to optimize the cost. We want to generate data to learn about the plant. Green hydrogen is also a very important feedstock for CO2 valorization projects. Whenever we talk about CO2 conversion to green ethanol, to SAF, etc., we need green hydrogen for which this unit can provide a input. And lastly, blending is the one of the most common feature. It can be blended either into CNG or CCGD systems. And as per our net zero targets, we plan to scale up this capacity of hydrogen to about 310 megawatt by 2030. So the various factors which we understand at present, which will help us to improve or put up these plants much faster is policy support for one, because at present the cost of hydrogen is pretty high. Solar power potential nearby to our units, technological advancements need to take place to bring down the cost of electrolyzer further, and value addition from byproducts. The various technologies that we are searching, which convert CO2 to valuable products like ethanol, SAF, etc., that kind of market can also help us to develop these hydrogen projects much faster, and economies of scale. This is a very small project, so obviously our cost of production is on the high side, but 70 to 80% is the cost of solar. So that can be optimized, and the size of the unit will also help us to reduce the cost of hydrogen as such. Thank you.
Thank you so much for the presentation. So I think we'll ask Mr. Ranjan from NHPC. What are the initiatives that NHPC has in that hydrogen? And if you can give it back in the
Thank you, Vivek. So, as you all know, that NHPC has been in the field of renewables since its inception. We are into hydroelectricity business. So that itself, it gives you a cleaner form of electricity since burning of coal and all. And NHPC basically started its journey in green hydrogen with the aim that we were, mandated that we are working in Ladakh also. We've got two hydroelectric plants there in Ladakh. One is in Leh and another is in Kargil. So that those plants, they have helped a lot to offset the carbon footprint of the energy requirement of Ladakh region. Otherwise, the power was being supplied by DG sets because the grid was not there. So after coming those plants, when they came there, so there was a natural, once the GH2 came into picture, so we thought that we'll be setting up some kind of energy requirement offsets, which will help the area to decarbonize its footprint, the energy footprint. So we started with two pilot projects in Ladakh. So one is a microgrid, which will be replacing the standby DG set requirement of our colony area. We've got a 45 megawatt hydroelectric plant there near Leh. So the DG set is used to supply power whenever there is power cut and all. So now we are putting up a microgrid. It is linked to a 300 kilowatt solar installation, solar PV installation, and it will be coupled to a 25 kilowatt hydrogen fuel cell. So in all, we have planned that plant so that it will be producing around 14 kg of hydrogen daily, which will be stored there, and it will be run through the fuel cell to generate electricity. So we are planning on daily. The plant is nearing completion. It will be completed in next month. So daily generation of 14 kg of green hydrogen, then that will be discharged through within the night itself to offset that power. That is one pilot project we are doing. Another one we are doing in Kargil, that is green hydrogen mobility. So there also we are planning to produce the design and all, everything is there, done, and plant is on order. It will be coming and getting installed there. 40 kg of green hydrogen production is there, apart with a dedicated solar installation, solar PV installation, and we'll be supplying to buses also, HFC, hydrogen fuel cell EV buses. Those will be run on the local area. So that will also help to reduce the carbon footprint there on the mobility side. And similar mobility project we are doing in Chamba in Himachal Pradesh also. So these are 3 pilots which we are presently working on in the green hydrogen.
जवानी की आपकी फोटो है जवानी की फोटो है अभी की फोटो काले बाल पता तो मिल रही है लेकिन ये जवानी की लग रही है स्कूल टाइम की स्कूल का कॉलेज टाइम
The SJVN is concerned, we are also primarily a hydro company. And we have moved to the renewable sector also aggressively. And so far as hydrogen is concerned, we have installed one multi-purpose project in our Nathpadakri power plant, hydro power plant at Dhakri in Himachal Pradesh. The project is able to generate almost 20 Nm³ per hour hydrogen that is used for our own consumption in hard coating of the turbines. And it is having the capacity to generate 25 kilowatt cells also, fuel cell also. Fuel cell will, in fact, will be using for reducing the carbon or reducing the use of DG set in not only and other places also. And taking into account the vision of the Honorable Prime Minister to reduce the carbon and to go for green energy, we are having an advantageous position as a green energy producer to go for this green hydrogen by supplying green energy by generating green hydrogen through our green energy project. And we are having future plan to develop green hydrogen hub. We are seashore, but currently we are having the only one project that will be a pilot project, and we are planning. And in fact, basically the 2 aspects are to be seen. One is the electricity cost, which is required to be used or produced for producing green hydrogen. For that aspect, we are also trying to tie up with the different international agencies for R&D and to reducing the consumption of electricity. Because there is a limit, 60 to 70% cost goes to the electricity for production of green hydrogen. And there is a limit to have the energy cost, because almost 2 rupees to 2.5, that is the only minimum rate we can have. But with the technological intervention only, either we have to reduce the energy consumption for producing the hydrogen, or we have to increase the per unit consumption and reduce the per unit consumption. That way we can do, and we are also aggressively in the field, but we are new and trying to develop with the other partners.
Thank you so much for that. And Joydeep ji, if we can know from you, apart from the usual use case of hydrogen and oil, what else are you doing including oil? If we can have us your perspective on that.
Thanks, Vivek, and good afternoon, everyone. Thanks for having me here. Well, I represent Indian Oil, and we have 9 refineries operating in different parts of the country. Hydrogen is a gas that is utilized in the process while refining oil and producing diesel, which is sold in the market. We consume an enormous amount of hydrogen in our refineries, which right now is being produced through the process of SMR from natural gas. So Indian Oil, as all of you probably are familiar, is a fuel selling organization of India, the largest fuel selling organization. But you may have also noticed that we are now transitioning into an energy company. And towards that, various initiatives have been taken. But specifically regarding green hydrogen, we have 2 pilot plants right now operating, or just about to start operating in our research and development center in Faridabad. One is through the electrolyzer method, and the other is an SMR. These are very small pilot plants of about 0.2 tons per day. And we have developed dispensing stations through which we will be fueling buses and vehicles for transportation. If you've taken a round out here in this Pragati Maidan, you have seen a bus parked over there, a hydrogen bus that we are fueling through the hydrogen that is being produced there. But these are, of course, pilot plants. Now, the big ticket project that is coming up is in Panipat Refinery in Haryana, 150 kilometers from here. We are about to set up a 10 kilotons per annum green hydrogen plant. And this is going to be followed up by a subsequent project which is going to come close on its heels, an additional 70 kilotons per annum. So that's going to be 80 kilotons per annum in Panipat Refinery itself, through the process of electrolysis. And we are going on a big commercial scale through build, own, and operate mode. And the plan for the next 6-7 years till 2030 is to convert the hydrogen that we consume in our refineries, which I mentioned at the start of that we're going to convert half of what we are consuming in the refineries from SMR generated hydrogen to green hydrogen. And that is 350 kilotons, I beg your pardon, per annum of green hydrogen by the year 2030, which is going to go up to 700 kilotons per annum by 2047. So plans are afoot, and the pathways are 2. One is through electrolysis, the green hydrogen, and the other is the CBG route, where we generate compressed biogas from through the biogenic method and then converting that into hydrogen. So that's the plan, and there's a lot of money on the table we are putting. And of course, the discerning ones amongst you may have already noticed that we have published a tender day before yesterday for the 10 kg plant in Panipat. So those who are interested may go ahead and bid for it.
Thank you. I think in round 2, I do have a few questions, and we'll start with Sarit. So I think in round 1, we were able to have a nice introduction and background on what companies are doing. What is really interesting is that the way we make methanol, which started off by coking and using a standard methanol process, is now being turned around its head. As per Sarit's presentation, when they are using the flue gas and using the CO2 from that to make methanol and even ethanol and perhaps even SAF. So, my request is to get some comments from Sir. Is that the future now?
It will be very, very difficult for me to say, because all the projects currently are at the pilot stage only. But yes, definitely, this is one of our main pilot projects which we are doing, which you just mentioned. I would reserve my comments for the time being. Let the efficacy be proved from the pilot before we start to say some more words on this. However, just digressing a little bit from that specific methanol query, moving on to the more on a larger landscape, the hydrogen part of it. We are very, very bullish on hydrogen per se for our mobility sector, number 1. And number 2, also setting up that green hydrogen hub that we are building for Purimatka. these two are going to, you are going to see significant capex from our side coming onto these places. And yes, once the, as I showed in my presentation, number of pilot projects on small scale, which we are doing, as and when the technology proves, we are able to prove the technology, we will be taking the further steps into commercializing it. Just adding to what Joydeep just said, that Indian Oil is also doing a joint venture with us known as Angel. So I just like to add what Indian Oil has been doing, and this is also we are setting up round the clock power plant, which will be fueling the energy to Indian Oil. So coming together as an integrated power company, we while we are having a large whole portfolio, I can tell the house over here with a lot of pride that by 2032, you would be surprised that we would be having a 40-60 kind of a mix of green energy in our portfolio. So NTPC, through its various joint ventures and also through its own arm, is significantly putting its foot forward into the green energy. I think for the time being, I would reserve I digress from the main question which you asked from methanol. We will like to reserve the real efficacy of methanol a little later for us to tell the house.
Joydeep, on the same lines, can you talk a little bit more about this population that you have with NTPC?
Well, see, the big demand in this today's world of green energy, when we talk about green hydrogen, everyone is talking about green hydrogen, but that's the end product. Now, what goes into that is green energy. And where do we get that from? If you look at the ambition that we have, which is to produce 5 million metric tons of green hydrogen by 2030. And 1 kiloton of hydrogen requires approximately 7.5 to 8 megawatts of energy. So 5 million metric tons translates to 40 gigawatts of renewable energy. Now that's the power requirement. So if you need to draw 40 gigawatts, you need to set up a capacity that's 3 times more. So that's about 120 gigawatts of green energy. Today, on date, the total green energy production in India is about 200 gigawatts. And to produce 5 million metric tons of hydrogen in the next 5 years, we need to additionally produce to another 120 gigawatts. So that is where the generation of green energy becomes very important. Organizations like SECI and NTPC, who are traditionally into power generation, they are the people who have to deliver on this. And on our part, we have entered into a joint venture with NTPC, it's called Indian Oil, NTPC Green Energy Limited, or INGEL. And I think if I'm not, I don't have the exact figures, but I think out of 2 gigawatts already, about 1.2 gigawatts is ready for production. Both solar, wind, as well as a part of it is also hydroelectric. So what we need to really focus on is where we are going to get that green power from. Once that is there, I think 90% of the challenges that confront us in the production of green hydrogen will be taken care of.
Thank you so much. And I think since we have spoken on the basic concept of additionality, which is that if you need to produce more hydrogen and export it, then it cannot be from the existing power. There is a need to put in more resources. And this next question goes to Mr. Vivek and Mr. Singh. If you can kindly let us know what are the expansion you have planned over the next 5 to 6 years, both in terms of your core business, which is GAIL, and also into expansion of other renewables like solar and wind, because hearing both of you, I think there are also some non-GAIL initiatives that perhaps want to come
Joydeep has rightly said that production of that kind of green hydrogen requires a lot of energy, also green energy, and that to run round the clock. Presently, like what we are learning from our pilot project, that the utilization of the electrolyzer based on just solar will be 50% of the time. So that will lead to higher cost of grid. So RTC power is definitely required. And in fact, ourselves along with SJVN, NTPC and SECI, these four organizations are also working as renewable energy implementing agencies. So in fact, MNRE has got a very, ambitious plan of adding renewable energy, and that too now we are moving to a round the clock sort of availability of green power, looking at the various requirements. So these four organizations between themselves, they are bidding out projects of around 50 gigawatt every year. So where we contract the capacity with the developers who come in and then they develop these projects, and those powers, those are tied up with the consumers. Because states, they have got an obligation to fulfill their renewable power obligation. I'm talking about normal power consumption, which is there in both. But those additional requirement of the green hydrogen as these plants they come up, I think that will also be met within the same bank with power bank which is being created. So that is it. And in fact, as we see that replacement of grey hydrogen in hard to meet sectors like fertilizers and petroleum and other steel industry, that is the main focus of the mission. But what presently we are doing, we are in a sort of learning phase that where the technology adoption is there. Our engineers, they are learning that how these these two plants they operate, the electrolyzer and the technology on those things. So this, for us, it is a learning phase at the moment. But definitely, unless we learn this, we cannot scale up. So that is the entire thing, and NHPC as it is, we also have our own development plan for renewable also. Those we are working, and in hydropower, we are already working on project of 10,000 megawatt will be coming up in next 7 to 8 years. In by 2030, we are going to scale up our present capacity of 7 gigawatt to around 17 gigawatt. So 10 gigawatt will be added in hydro field. And on solar also we are working. So we have got around 2 to 2.5 gigawatt projects which are presently there in our portfolio, which will be coming up. And we are looking for more opportunities later also. So definitely all these efforts, they will be helping to fulfill the demand in the GH2 power segment also.
Likely said by Mr. Vivek, that we are having our own target of our capacity addition through development mode. Plus, we are also doing project under DR. NTPC, SJVN, NHPC, SECI, they are having a target of 50 gigawatt. Besides that, there are rooftop projects are also going on at different stages. Different states are also coming with their bids. The capacity addition in the country will not be 60 to 70 gigawatt, less than 60 to 70 gigawatt per year. And this capacity addition, so far as concerned, we are going in 4 vertical. Plain solar, plain wind, hybrid, and FDRE. In FDRE, we are going for a tender of 1 gigawatt, the actual capacity will come out to 2.5 or 3 gigawatt for having the fixed and dispatchable supply, that is RTC. Similarly, in hybrid also, it will be almost 1.5 to 2 times to have generation in hybrid mode. So in that case, it is not the capacity is coming to about 60 to 70 gigawatt per year. The capacity will be almost 80 or 90 gigawatt per year. It will be coming, and that will cater the demand, growing demand of the country for normal use or for the production of the green hydrogen. So far as SJVN concerned, we are currently having a capacity of 2.5 gigawatt. We have planned to develop capacity of 25 gigawatt by 2030 and 50 gigawatt by 2040. And in that case, most of the capacity is coming through renewable sector only. By renewable, I mean solar and wind, and almost 9 gigawatt will be added, will be there from about 7 gigawatt project of hydro will be added in next 6 to 7 years. In that way, we are having good quantity, and mostly in the country also, in DISCOMs also, they are preferring for the RTC power. And we are in India also, we are going for the FTRE and RTC power. And we are not going, we are not attracting developer, but even if we are participating as a developer in other space, like I can participate in the bid of NHPC, SECI, or NTPC, or NTPC can participate in bid of SJVN, NHPC, or SECI. Similarly, NHPC can participate in other bids. We are doing that also to develop our own capacity as a developer. I hope the demand will be met, but there are a lot of challenges also. Challenges of land acquisition, challenges of grid connectivity, service station, etc. But there are fast, I think, fast development is going on, and both the ministry, MNRE and Ministry of Power, is coordinating with each other and monitoring each and every project very meticulously at the level of even secretaries and ministers.
Thank you. Mr. Chugh, since you very nicely explained all the plans of GAIL to us, it was particularly interesting to see that you have already done scope emissions 1, 2, and 3, which you covered in your presentation. Can you talk a little bit on that, and how does natural gas play an essential role in industrial decarbonization compared to fossil fuels? Because it is more cleaner, and I mean, how do you see yourselves as contributing to the decarbonization of industries and providing the fuel which is important for industries and industrial flow?
So as I included in my slides also, natural gas is helping the other companies achieve their decarbonization goals. But for us in GAIL, we consume small bit of energy while transporting. So for us to move away from carbon emissions to decarbonization, we need much cleaner fuels. So on one part, other companies, once they switch on to natural gas, about 80% of their targets are met in one go. So for us, we need to move to fuels like CBG, which is a green fuel supposed to be, and also hydrogen. So if you talk about other companies, perhaps it is quite simple. They can immediately move to LNG wherever the requirement is, depending on cost economics. And for GAIL, these fuels are at present very costly, CBG and hydrogen. We have to treat very cautiously, but fortunately, the cost elements are coming down. Solar power used to be very costly, more than 10 rupees few years back. And now it is selling less than 1 rupee on exchange in daytime. And RTC power is also coming at 3 to 4 rupees. So one element has been taken care of. Second is electrolyzer. Now so many companies are setting up their own electrolyzer plants. We hope to see a drastic fall in the cost of electrolyzer itself. And we ourselves have set up a plant to gain some operational experience to optimize and to improve upon that. And last, there are problems perhaps in water. So there are technologies and research going on for converting maybe seawater, although it's very expensive. But things are moving in the right direction. And we hope that within the next few years, we will be going more towards hydrogen. And as such, there's some cost element to the environmental benefit also, which needs to be put into it. So still it will be economical in the long run.
do you have any general comments on the commodity price of NG? Will it remain the same or it's very difficult question, etc. Many promise failed. So during Ukraine war, the gas prices went up from $4 to about $80 and so finally in between. For example, for now, fortunately, they have come down to $8 to $10. I'm not an expert on that. They are no experts. Everybody fails to show the car themselves. So let's hope they stabilize at these levels, don't go from there. So $8 to $10 is convenient enough for the country to manage the fuel supplies for things. Joydeep, there is a lot of discussion about CCUS that is going with oil companies abroad. And especially global oil companies are using it for end of oil recovery, where they will use CO2 to extract more oil. But I mean, having said that, do you see any potential for CCUS in India for oil and gas operations, or we have a different application altogether?
No, there is certainly, because we as a company, Indian Oil, we have our ambitions of becoming a operationally net zero company by 2046, 1 year before the 100th year of India's independence. So there are various measures we have put into place. It's not just the enhancing the efficiency of the combustion that happens in the different processes in the refineries, but also the kind of fuels we use. And regarding the end of run you mentioned, I suppose you were hinting at extracting oil from the oil rigs. People up from upstream oil exploration will be better suited to give a response to that, but I can talk about downstream and refining. CCUS is in a very nascent stage, I'd say, but all the measures are being put in place, and I'm sure that in the next 5 or 7 years, we'll see a majority of all CCUS efforts that we are putting into this. But I'd like to just give a rejoinder on the green hydrogen thing, since we are here to discuss green hydrogen. We have been focusing on green energy, the green power that is required for green hydrogen, and also probably passing remarks about the efficiency and the cost of electrolyzers. But we are missing the elephant in the room, which is water. Even if you look at the stoichiometry, for every kilogram of hydrogen that is produced, you need 9 kilograms of water. But that apart, the process also consumes a lot of deionized water and utilizes water. So I think, if I'm not mistaken, 1 kilogram of hydrogen, green hydrogen, will actually require about 40 to 45 liters of water. That is going to be again another big challenge. Where do we get that water from? And maybe desalination could be a solution, but that too, would probably be more applicable for the installations on the west, on the coast. What about the inland efforts of green hydrogen? What about the inland setups? Where do you get the water from? So that's an area we really need to look at, that where all that water is going to come from.
Thank you so much. And I think now we can have one round of audience questions.
Mehta Railways, question for GAIL and IOC. What's the current status of blended hydrogen in LNG specifically?
Well, as far as IOC is concerned, we are not really blending hydrogen in LNG. There was an experiment, you may be aware, we had set up a little SMR plant here in Rajghat in Delhi, and we blended the CNG with hydrogen that we call it hydrogen enriched CNG now. TTC buses were run on that fuel. We got a very good result from that. So that was more on an experimental basis. The experiment was successful, and we have now dismantled the facility at Rajghat. But as far as our pipelines are concerned, we have cross-country pipelines, and where there's LNG that we're importing from GAIL, we're buying from GAIL. So I suppose there is some kind of talk going on about injecting hydrogen, but there's also an issue about a concern about how the metallurgy is going to react to the injection of hydrogen in CNG. So the gas transportation experts from GAIL will probably be able to answer this question better, but from an end user's perspective, this is how things stand with the available.
So the advantage of hydrogen in natural gas is same whether you use it as PNG, CNG or as liquefied natural gas. So bringing hydrogen into LNG properties, I don't think at present we are also working with this. Very aggressive.
Last mark from GAIL India. My question to Sarit sir, CEO NHPC. So what is the status of Lara plant, CCS plant coming up at Lara? Current status?
Still in the pilot stage. We are moving forward. We're setting it up over there.
Construction work has started.
Yes.
By what time do we expect the commissioning?
Let's hold on for this for some time.
Thanks.
Myself, Sandeep Malik from Windows. So I just wanted to know that you said about that hydrogen locomotive. Where do you see that can be used? Because I think that electric locomotives are more efficient than.
You want me to answer this? Yeah, at all the places where we are tending to use green hydrogen, the other alternatives currently are definitely cheaper. So that part well taken. However, we are looking up at decarbonizing. And when we are looking up at decarbonizing, there are certain areas which need to be decarbonized more. And one of them is, as I said, in our power plants, coal is hauled from long places. So in case, in the absence of, currently we are using diesel as well as the electric locomotives. Now, if we are able to prove this, then this is going to go a long haul, and then why not into the railways and other places. So this is a pilot that we are trying to do at this point of time to find out the efficacy. The aim is, again, for the house, we need to differentiate at this point of time when we talk about pilot and the cost part of it. The cost is definitely, when we talk about green hydrogen, is a very different subject, wherein partly touched by the panelists, how to bring down that cost. That would include bringing down the electricity that is used to produce green hydrogen, the electrolyzer cost, and the other parts of it, which are definitely technology driven at this point of time, are higher. But these are on the other side, the usage where perhaps decarbonization will help us. And these pilots, if proved, would be a very viable place wherein when we are able to bring down the cost of green hydrogen, we can move it fast.
Good afternoon. I'm Pankaj Patil from Mineral Corporation Limited. My question is to GAIL. Mr. Chugh, can you please tell us the estimated cost of green hydrogen production from your pilot plant? Because as far as we are concerned, we are going to use green hydrogen, and for sure, our cost of production is around $2.2 per kg. So, what about GAIL for this pilot plant?
See, if I take my solar cost at 4 rupees a unit, my actual cost is working out to about 5.5 to 6 per kg.
Okay.
Since it is a pilot plant, obviously the prices are much more.
Mr. G.V. Shankar.
Well, before you end this, just as a rejoinder, I would also like to add few things when we talk about green hydrogen. See, green hydrogen technology is currently on a nascent stage. We would definitely need a lot of hand-holding, the industry per se, to bring, by the time the cost part of it comes down something like the solar cost. When we started, it was 15 rupees. Today we are talking about 2.5 rupees, and if there is certain incentives which are given, it can go down to below. Likewise, each and every integral part of the green hydrogen production, the industry per se has to jointly collaborate not only on the national level but also at the international level. There have to be something like the renewable power obligation, akin to that we will need to have the green hydrogen usage obligation, which would translate to industry. So for the time being, anything that we are doing, as you see, the entire panel and the entire industry is only on the pilot scale. As the technology matures, the cost is bound to come down. We are seeing it in all aspects of renewable, whether it be batteries, whether it be solar. So why not on this? So we get ready. We don't miss the bus. We get ready with our infrastructure. We get ready with our product use. And by the time we get the good pricing for it, we are all set to go and make the work.
They say vision without action is a daydream, and action without vision, a nightmare. Who better than the learned panelists to have intertwined the two and make tomorrow a realistic and an attainable, greener, cleaner, and a more sustainable future. And our gratitude abound to you all distinguished speakers and members for steering such an insightful session of deliberations. May I now please request the esteemed session moderator, Mr. Vivek, to kindly do the honors of felicitating this distinguished panel with a token of our appreciation and gratitude. Felicitations to Mr. Parivesh. May we please request you to step forward. Felicitations to Mr. Vivek Shrivastava. Felicitations to Mr. A.K. Singh.
कैमरा किधर गया भाई?
Felicitations to Mr. Joydeep Choudhury. And felicitations to Mr. Sarit Maheshwari.
6B color.
And if we have you with us, sir, Mr. Anandya Parira from the Ministry of New and Renewable Energy, to kindly do the honors of felicitating the esteemed session moderator, Mr. Vivek Bhardwaj, for steering this session as we unravel the pearls of wisdom from the PSU's perspective. Thank you very much. With that, ladies and gentlemen, we come to the conclusion of this session and right away begin with another session, which is about the digital approaches for the better implementation of the hydrogen ecosystem. We'll take 2 minutes, deck up the days, and commence with the formal proceedings right away. Thank you.
Recording.
The next